Next question was to copy the diagram below into your answer book and complete the ray diagram to form a real image. Okay, so let me just draw properly here now. So we have a straight line like that, and then we have a converging lens. We have a focal point there, and we have a focal point there. They should be equidistant, and we have a little arrow like that. Okay, so we're going to go in parallel, so you should be using a ruler here, in parallel and out through the focal point. Okay, so we're drawing just arrows to show the direction. We can go in through the center of the lens and out the other side like that, or we can go in through the focal point and out parallel. And if you have drawn it properly with your f's equal distance, then you go in straight, in parallel, out through the other focal point, that's this here. You can go in through the center of the lens here, and it's straight out the other side and not change your angle, or you can go in through the focal point to here, to the middle of the lens, and then out parallel. Okay, so they're all coming out the other side like that. Okay, we're going through. That's coming in through the focal point, out parallel. And then finally, we draw our other arrow over on that side. So it's being inverted. It's upside down. All right. The power required to clearly view a nearby object is 38 per meter. So remember, power is a weird unit of per meter. A person with an eye defect has a maximum power of 32. Calculate the power of the lens required to correct this defect. Okay, so we have that they actually need 38, but they're at 32. So we have to find the difference. So the difference in power is 6 per meter. Okay, that's the difference in power between what they can do and what they actually need, right? So there's a difference there, which is a problem. Now, we know from the log tables and from our classes that power is 1 over F. Okay, 1 over F. So all we need to do then is say that we want the focal length. So actually we can do it the other way around. We say that F is 1 over P. All right, so that means the focal length. So essentially, to get up to the 38, we need a lens of power 6, right? So we need to add that in. So what's the focal length? Well, it's 1 over 6, all right? And you get your calculator and you do 1 over 6. I think it's 16. It's a sixth. Thank you, calculator. Which is 0.166, and it goes on and on. Let's just call it 7 meters. That's the focal length, so 16 centimeters or so. All right. Light undergoes refraction as it passes through a lens. What is meant by refraction? Okay, so refraction is the bending of light as it travels from one medium into another. Okay, and say that is it. The bending of light as it travels from one medium to another. Cool.